Hey everyone, my name is Patrick. I am the manager of the Applications Engineering Department here at Patterson-Kelley. We're going to get started. For anybody who wasn't on a couple minutes ago, just as a reminder, we are muting everybody. Please stay on mute when you have the opportunity. And any questions you have, there will be an email address at the bottom of each slide that you can send in your questions to, and we will be responding them at the end of the session. This is a recorded session, so if you do come in late or you have somebody that you wanted to see this as well, we will have a recording for this for you to have at the end that we will send out to the participants. Like I said, welcome, and we're going to get started. Okay, so the beginning of this session is intended to talk about our newest product in the water heating line, our PK HiDRA. It is our latest water heater from Patterson-Kelley. There are some specific features, but the biggest thing here is that we have both a 1 million and an 800,000 BTU model readily available today. As far as the materials go, we are currently using a duplex alloy stainless steel coiled heat exchanger in inclusion of a duplex alloy stainless steel storage tank. This is a 2200 series stainless steel. The reason we use those materials is because they give you a high level of corrosion resistance. It allows you to eliminate things like anode rods that would normally be required in other materials. Having the materials be the same on the storage tank as well as the helically coiled heat exchanger allows you to continue with no dissimilar metals, so there is no fighting of the materials inside of the tank. There is the unit itself is downfired, which means that all of the gas equipment and burner, blower, gas train, etc. is all located at the top of the unit. And I'll show you what that looks like a little bit later. We use an anticipated temperature type control with our dedicated recirculation line on the tank itself. The unit is an ASME CSA certified Section 4 HLW rated vessel, meeting ASHRAE 90.1 standards as they stand today, as well as NSF compliant. Here are some pictures of what the unit actually looks like. Like I said before, the burner assembly, blower assembly, gas train assembly are all located at the top in that Millennium Falcon looking device sitting on top there. The control panel assembly sits on the front. So any of your wiring connections will be directly connected to that box sitting in the front there. If you look at the right-hand side, you see our insulation jacket. The unit itself has a steel insulated jacket with 4 inches of foam surrounding it. You can also see in here you have a recirculation line assembly, and we'll talk a little bit about what that does right now. So unlike some of our other units that we have in some storage tanks, you have some potential for some stratification inside of the vessel. And that can be fine. The system can be designed for that. But really, what you want in a smaller vessel like we have, our 130 gallon capacity, you want that to be thoroughly mixed. Because what that does, it allows you to know exactly what temperature is exiting that heat exchanger and going into your system. Our temperature control is located in that recirculation line that you see there. What that does is it allows us to anticipate any changes in flow or in temperature that are occurring within the system, allowing us to tune in our temperature control to plus or minus 10 degrees. A little bit of an eye chart here, but the general dimensions for this unit reach 84 inches in height. They are a 34-inch diameter. You can see you have varying forms of connections here. You can see on the picture, you can see the recirculation line at another angle. You see all of the connections, again, like I said, that you need to really access are through the top. You can see that in addition, you have a couple other bolt holes, which we will talk about in a moment. The biggest points here are you have a 1-inch dedicated recirculation line for the building. So you have one dedicated port for pulling all of your recirculation temperature in at the middle of the tank. That allows you to come in at the neutral point of the tank itself. What also, if you see, our recirculation line is not far from it, allowing that flow to be circulated within the tank evenly. You have a condensate drain which sits at the bottom. That is a 3/4 inch connection. All of our units come standard with a trapping type technology to allow you to pull into a condensate receiving system at your leisure. There is a 2-inch hot water return line coming in at the bottom of the tank and a 2-inch hot water supply line exiting the tank at the top. Additionally, you have a 1-inch drain valve to do routine maintenance to properly drain the tank if you do need to do any particular service. Included on every unit that we sell, we have a 3/4 inch temperature and pressure relief valve that is also readily available. Some general specific information for the unit itself. The fuel type we use is natural gas only, capable of handling minimum inlet pressures of 3.5 inches water column up to 14 inches of water column. Like I said before, it is available in an 800,000 and 1 million BTU unit with a maximum output with our rated efficiencies from CSA at 940 and 752,000 BTU. Our turn down capability is 5:1. That is a CSA maximum that we can use in the unit. So therefore, our maximum turn down can be at 160 to 200,000 BTU. Shipping weight, taking account of no water inside of the unit, is 1,000 pounds. Operating weight, with the water included, is 1,920 pounds. Like I said before, the domestic water content is 128 gallons, just under 130 gallons. Our power supply is 120 volt. Our maximum pressure operating is 160 psi. Because it is an ASME Section 8 pressure vessel and an ASME Section 8 HLW stamped device, the maximum allowable temperature is 210 degrees Fahrenheit. Our maximum operating temperature, that is the maximum temperature that our neurocontroller is able to set, is 180 degrees. This allows for multiple applications, including hospital use, any boosting temperature use up to 180 degrees in your apartments and your schools, whatever it may be. If you look at the coiled heat exchanger, the heated surface area is 107 square feet and just under 133 square feet on the 1 million BTU unit. These equate to a recovery rate in the range of 1600 to 900 GPH depending on what your incoming and outgoing temperatures are. The unit is dual certified as a Category 2 or Category 4 appliance via ANSI Z2113. Category 2 appliances have the capability of running in a negative 0.1 inch water column and a negative 0.05 inch water column. Category 4 appliances meet the same on the positive side. Exhaust can go all the way up to 1 inch water column, which is different than a lot of our other standard models. HiDRA venting availability. We are certified to operate with AL29, 316L stainless, CPVC, and polypropylene. It is not rated for PVC service due to the fact that these units are condensing and PVC does not operate in those temperatures. It tends to, as anyone knows, it does terrible things once it starts getting into those condensing temperatures. The combustion air intake ductwork can be constructed out of CPVC or PVC, again, because now you're talking about intake. Single wall galvanized stainless steel or stainless steel with a 6-inch inlet connection. Make sure when you're sizing these that you observe the SCFM requirements because that is also going to determine how the unit operates. Motorized air dampers are available upon request. These are rated for both single unit through the wall and through the roof venting, as well as combining vents with a draft inducer. If you see on the left-hand side, you see a picture of what we're talking about there. Due to the fact that all of the gas equipment is located at the top of the unit, the service clearance is only at the top of the unit. You need a minimum of a 16-inch clearance above the device to be able to access all of the proper annual maintenance units. CSA mandates a 24-inch service clearance to the control panel, but if you look, the service clearance on all the other sides is 0. CSA, though, mandates, again, 2 inches minimum recommendation. This allows you to essentially stack the units next to each other without compromising additional square footage that you may or may not have. Like I said, the unit itself has the ability to be used in hospitals, schools, offices, and apartments, as well as a myriad of different locations such as hotels. And the reason for that is because all of these locations require a varying load of temperature control that's now capable for the unit itself. You have offices that have varying flows depending on the workday, apartments that have cyclical loads such as mornings and evenings, hospitals which have shift changes and lunch and dinner needs for the residents at the facility, as well as in schools. All of these would require a small volume amount of storage in the vessel itself. The anticipated recirculation line allows you to be able to accommodate those demands at any given time. We are able to anticipate any temperature changes in a matter of seconds, which allows us to prepare the firing of the unit to the correct requirements. Like I said before, this was a short presentation, so I am open for questions, and we'll hold questions open for another 10 minutes. So let's see what we've got here. Give me 1 second. Someone asked me to go over the minimum output capacities. I can do that for sure. So the minimum output capacities for the unit are reflective of the 5-to-1 turn down capacity. So that means that each unit is capable of handling, the 800 million BTU is capable of handling down to 160,000 BTUs, and the 1 million unit is capable of handling down to 200,000 BTU. A couple people asked, is there any anticipation of coming with smaller sizes for these units? It is a plan for the future. At the moment, we are focusing on other units, but we are definitely seeing how the reaction of the field is before we expand further. Oh, another good example question for an application. It was, can the HiDRA be piped to an external storage tank? Absolutely. So the HiDRA has a capacity of, like I said, just under 130 gallons. But that doesn't mean you can't pipe it to a pre-existing storage tank or to a new storage tank if you think you need an additional capacity. Again, I see this being a potential use in process loads as well, and those batch processes could deplete that 130-gallon storage tank fairly quickly. I would see that as a definite use for an external storage tank. And nothing says this can't be used in a retrofit application as well, where an existing storage tank would be. This would be a terrific addition to any of those types of scenarios. If you are a representative within our group, you already know that we have one of the best boiler certification programs in the country, as well as anybody who is an engineer, service contractor, mechanical contractor. You have the ability to attend those through our representative channel. All you would need to do is contact your local representative, and they will get in touch with us to set you up with a class. That can either be here. We do a class here almost every other week during the summer and into the fall, as well as if the class is large enough, we could additionally do training at your facility. Some person asked, is the steel treated or is it passivated? So 22 series stainless steel is a passivated stainless. So what it uses is an austenitic and a ferritic stainless merged together. If you remember at the picture, and actually I will try to go back to it now, see if I can drive. Here, you can actually see a picture of what that looks like. So again, if you look at this picture, you can see that it really is the two types of stainless blended together. And what that is one of the keys to its corrosive resistance, and it extends the life of the vessel itself. Another good question from one of our representatives is that can the HiDRA be set up for cascade? The plan is that this unit uses our patented Neuro controller, so all options that the Neuro has currently, including cascading, will be available in the future. If people have particular questions on pricing too, I'm seeing a few of those as well. We can talk to those offline. Like I said, our representatives are, I always like to mention this when I have an open group of people, is that we have a rep to market strategy. So what that means is that our representatives are the ones you'll be contacting for pricing and availability. If you have a question on that, you can always go to our website at harscopk.com and you can locate your local rep, and they'll be more than happy to assist you. Obviously, we have more than just the HiDRA product available to us, so there are several other things that you could be asking questions on in comparison for pricing, and obviously they will have the ability to give you that answer. A couple people asked about how does that anticipate the temperature return on the unit. To explain that a little better, I will show a picture, possibly, there we go, that we had before. So what's actually happening here is that copper line is recirculating the water throughout the entire tank. It may seem, because it's sitting higher, that it's not actually blending the majority of the tank, but the reality is that it is, because as the water is forced through, it actually cycles it around through the entire tank. We've actually designed we've selected the pump on that unit to overflow more than what it actually needs to anticipate temperature control, which also additionally gives you some more sensitive temperature control as well as thorough mixing, which is part of that question. A couple individuals have asked of what the maximum temperature rise would be available for the HiDRA product. Remember that the HiDRA product can actually, because of that recirculation line, operate at zero flow, because it'll constantly be mixing the flow. So on top of being able to handle 0 GPM passing through the unit, you could also essentially run the unit at near freezing conditions all the way up to the maximum temperature. There's no limit to that operation. Okay, it looks like most of the questions have been answered so far. I'll keep on the line for a couple more minutes, but just as a reminder that this recording will be sent to you and everybody that has signed up for the webinar. So if anybody has any additional questions, feel free to review that and then contact us later. We did have one other question about concerns with thermal shock. Because of the helical coil nature of the exchanger itself, it does allow for some flex, so questions and concerns with thermal shock are mitigated because of the design of the exchanger. Again, like I said, is that we've done some pretty extensive testing with the models that we have available to us. One of the biggest things for us is that beyond the CSA and additional testing that we're doing for the country, we put our units through a fairly rigorous test before it even gets to that point. We're testing different things like gas trains, blowers, and everything included. So we're trying to push it to the maximum of what the unit is capable of. Thermal shock being one of the things we're looking at most. So, and if there were any concerns with that, we would have seen it already. There were a couple questions concerning water quality. So I always refer to our manuals that state what the potable water quality standard is. Water softening is something that you will be seeing in the future. Obviously, you don't want to be shocking or softening the water right before any appliance. So that's one thing I always like to point out for an application. But know that even those types of applications with heavier water softening are capable, as long as you're not, like I said, putting the softener right in front of the unit itself. So I think the final question that I'll end this discussion with is, some people have had the question about how the unit is actually condensing. Well, if you remember what I said in the beginning, the unit is downfired, so the flame is actually propagating at the top of the unit. As the helical coils extend down to the bottom of the tank, the flue gases are condensing. that's the main reason why the condensate drain is at the very bottom, is because we're maximizing that full length of that unit to condense the flue gases in that operation. Obviously, at the bottom, the hot water return or the cold water intake, whichever you'd like to call it, is going to have the coldest water coming in, accelerating the condensing flue gases. Just keep in mind, like I said, this is recorded. If you have additional questions, feel free to reach out. There are some questions about how the controls integrate with our unit itself. I could spend another hour talking about how the different control features that you have available to you. I would actually suggest that you send those out to me or contact me directly. If you're a representative, obviously you have my availability. If not, you can always contact the marketing department, and I'll be more than happy to reach out to you and respond to those questions about how our unit actually controls. Look for potentially in the future, something for the channel is a neuro control type presentation similar to this for our representatives. So if you have that additional question, feel free to ask. Thank you again, everybody, for attending. If there's, like I said, we'll send the recording out in short order. If there is any problems or you have an additional person that would like to get the email presentation, feel free to send us it out, and we'll be more than happy to get that to you. Thank you again. Have a nice day, everybody.